Imagine, for a moment, the deep, impenetrable blackness of interstellar space. Not the kind of dark you find on Earth, but a void so profound, so utterly empty of light, that it feels ancient, almost primordial. It's here, in these vast, frigid nurseries between the stars, long before the first spark of a sun had truly ignited, before planets had even begun to gather their swirling nebulae into solid ground, that the fundamental ingredients of life were already patiently, quietly forming. A silent, slow dance of cosmic creation unfolding in the deep cold. For a long time, when we considered how life's essential building blocks, like amino acids, might have emerged in the universe, our thoughts often gravitated towards intense energy. We pictured violent volcanic vents, or the searing kiss of lightning strikes on an early Earth, or perhaps the relentless, sterilizing glare of ultraviolet radiation streaming from young stars. It seemed logical, didn't it? To forge something as complex as an amino acid, the very foundation of proteins, the machinery of all known life, surely required a powerful energetic kick. The universe, in our minds, needed to supply that energetic catalyst, perhaps in the form of a nascent sun's harsh UV light, to get the chemistry of life started. This thinking presented a fascinating challenge. If such specific, high-energy conditions were needed, then perhaps life was a rarer, more precious occurrence, dependent on very particular cosmic circumstances. But the cosmos, as it so often does, has a way of surprising us, of quietly rewriting our assumptions. Recent groundbreaking research has unveiled a discovery that radically shifts our understanding of life's cosmic origins. It turns out that glycine, one of the simplest yet most profoundly important amino acids, a key player in the intricate dance of life, may not need that energetic kick from UV radiation at all. Researchers have now demonstrated that glycine can form through what they've wonderfully termed dark chemistry. Think about that for a moment. Dark chemistry. No harsh ultraviolet rays, no searing heat. Just the subtle, persistent interactions in the deepest, coldest reaches of space. This isn't just a minor tweak to a scientific model, it's a fundamental reimagining of the recipe for life. It suggests that these vital ingredients aren't just possible, but potentially prevalent, forming under conditions far more common and widespread than we ever dared to imagine. It changes the narrative from life being a lucky break in specific energetic zones to life's building blocks being an almost inevitable outcome of fundamental cosmic processes. So, how does this dark chemistry unfold? Picture those vast interstellar clouds we just spoke of, swirling with gas and microscopic dust. These tiny dust particles aren't just inert specks, they're often coated in thin mantles of ice. In the silent, slow-motion ballet of these clouds, these ice-covered dust particles gently, almost imperceptibly smash into one another. Imagine them as cosmic bumper cars, but instead of loud collisions, it's a quiet, persistent nudging. When these particles collide, they fragment. Their icy mantles shatter, exposing fresh surfaces. And then, here's the magic. The broken fragments and newly exposed molecules within the ice can reassemble. In this chaotic yet purposeful dance, atoms and simple molecules are brought into close proximity, allowing them to react and combine in ways that wouldn't happen in the more sparse gas phase. Glycine, it turns out, can be one of the compounds quietly forged in this frosty, dark crucible. It's a testament to the universe's ingenuity, using simple physics, cold temperatures, and abundant dust to manufacture complexity, one gentle collision at a time. This isn't a violent process, but a patient, steady accumulation. And this is perhaps the most tantalizing aspect of this research, a realization that ripples across the very fabric of our understanding of universal habitability. If amino acids like glycine can form through dark chemistry in interstellar clouds, it means they can be present before those clouds even begin to condense into stars and planets. Imagine the very building blocks of life waiting. They're not waiting for a sun to shine, or a planet to form, or oceans to gather. They are already there, pre-existing, folded into the very raw material from which solar systems eventually emerge. So, when a new star system begins to spin into existence, drawing in gas and dust from its natal cloud, it's not just pulling in hydrogen and helium and a smattering of heavier elements, it's potentially pulling in a pre-made cocktail of amino acids, ready to be incorporated into forming planets, comets, and asteroids. The universe isn't just providing the stage for life, it's providing the intricately designed Lego blocks from the very beginning. This truly elevates the prospect of universal habitability. Once formed in these vast, dark cosmic nurseries, these amino acids aren't just sitting there. They can be incorporated into comets and asteroids, which then become the universe's own gentle delivery system. These icy travelers, often called dirty snowballs, can carry these vital organic molecules across vast distances, depositing them on newly forming planets. It paints a picture where the seeds of life are not a fluke, but a widespread, almost inevitable endowment. This suggests that the potential to birth all sorts of extraterrestrial life, from the simplest microbial forms to complex beings, might be baked into the very recipe of the cosmos, ready to be distributed wherever conditions allow. So, the next time you look up at the vast, dark canvas of the night sky, consider this profound thought. Hidden within those seemingly empty spaces, in the frigid embrace of cosmic dust and ice, the fundamental components of life were quietly, patiently being formed, long before any planet existed to host them. It's a gentle reminder that the universe is not just vast, but intimately connected, weaving the fabric of existence from the smallest particles to the grandest galaxies, all in a dance of dark chemistry and endless possibility. What are your thoughts on this incredible revelation? Does it change your perception of life's place in the cosmos? Share your reflections in the comments below. And if you found this journey into cosmic origins as fascinating as we did, please consider liking this video and subscribing for more stories from the frontiers of science. Thank you for listening.